Hi, welcome back, or welcome if you're new. This is Tammy and I do math for coffee, and today I'm going to show you how to solve a system by graphing. You're going to be graphing using slope-intercept form of equations. If you've never graphed with that before, I'm going to put a link up in the description for you so that you can review that real quick. Or we're going to start with this first one. Y equals negative 1/3 x minus 4. The y-intercept is negative 4, so I plot that point. And that is at negative 4 on the y-axis. Then from here we have to find a second point, and to find that second point we're going to use the slope, which is 1/3, 1/3. You go up one box and then we'll go over 3 boxes. Watch me count it out. And there's our second point. Now from here you just connect the dots. So grab a straight edge and draw a straight line going through those 2 points. And that is the graph of the line y equals 1/3 x minus 4. Now this line, we're going to need to graph that one too. It has a y-intercept of positive 2. So I'll go up to the +2, put a dot there, and then we use the slope to find the second point. Now this slope is negative 5/3. So negative means you're going to be going down first, but we'll go down 5 units, and then we'll go over 3. Oh, that worked out real nice. Do you see how we landed on the exact same point? Because that's really what we're looking for with these two lines, is we are looking for the intersection point. So where these two lines cross is a solution to this system, meaning that point, the x and the y value of that point, will work in both of these equations. And that point is 3, negative 3. So we have found the solution of the system by graphing. You may already know how to graph lines, so really what this is coming down to is just graphing two lines on the same graph and seeing where they cross, if they cross. So this first one, the y-intercept is +3. Now the slope is negative 2. You want to rewrite that as a fraction. Negative 2 over 1. And that means we're going to go down 2 boxes over 1 box. And there's our second point. Hey, if you got some value out of this, it would help me out a lot if you would like and subscribe so this channel can grow on YouTube. Thank you. Let's do that again for the second line. Y equals 3x minus 2. The y-intercept is negative 2. Dot goes there. We're going to use the slope of 3, but it's 3 over 1. So that means we'll go up 3 because the 3 is positive, over 1, and there's our second point, which is super nice because that's also the intersection point. We found it that way. Sometimes it doesn't work out quite so slick, but these examples in the beginning here are to show you how this works. The coordinates of that point, 1, 1, will be a solution for both of those equations at the same time. All you have to do is substitute them in there and see that it works. Changing the equations up just a little bit with that x equals 2 one. We'll start with the y equals negative x plus 4, put the y-intercept here. Now what's tricky about this one is a lot of times people don't recognize what the slope is in front of the x. When you see that negative x, that's the same thing as negative 1 times x. Put that over 1, so that means your slope is negative 1 over 1. We're going to drop 1 box and go over 1 box. And so there's our second point. Line is graphed badly. Sorry, it's going to work. We're still going to figure this out. All right, x equals 2. Well, now this is one of those horizontal or vertical lines, and sometimes it's hard to remember. So I put the point on x equals 2. We have to draw a line that goes through that point. All the x values are 2 all along there. The y's might change. Y's are heights. But the x is not going to change. It'll always be 2. So there is our intersection point. And it is at 2, 2. So if you need to review graphing in general using the slope-intercept form, click into this video. If you would like to move on and see how to solve systems algebraically using substitution method, click into this video next. Bye. See you next time.